Okay, so sorry for the time. This morning I just posted a link on Trunk on Notion so that maybe you can update your rate of return on portfolio. Okay, so you can just spend maybe some time to fill up your rate of return for last week. Okay, so I'm gonna show you here. Because from now on every week I think you should post your rate of return every week, and then maybe we can discuss your portfolio performance. I think that will be more interesting, so that everyone in the class can exchange ideas, okay, among the maybe you have a very special investment strategy, so I think that will be very interesting. Okay, so this is one thing that you should know, but of course we'll discuss that later. Okay, so today we're gonna move on a little bit to the next chapter. So let me check the okay, before we start, we have I just found another website, because this morning I just found this website. This website is called Seeking Alpha. Okay. So this website also provides some tools to help you to select your investment target. For example, like stocks, ETF, etc. Okay, so maybe you can try to create your account, and then we have some menus on the left hand side here. For example, like stock screener, ETF screener, okay, and of course including some top stocks and top ETFs. Okay, so I think if you are not if you plan to use, okay, different website to provide you with different ideas, maybe I think this website is also interesting. Okay. Okay, this is about the screener, okay, for ETFs. Okay, so that's what we need to do here, and then I'll go to the University. Just a minute. So next thing is about your homework. So I remember last week I extended the deadline of the homework for maybe 4 or 5 days more. So I think that'll be a little bit easier for you to complete the homework. Okay. So last week we have a homework 2. Okay, homework 2. Let's just take a quick review of the homework. So basically, homework includes 2 chapters, chapter 5 and chapter 6. Okay, so in problem number 12 and CFA number 1, and chapter 6 is problem number 10 to 12 and CFA 1, 2, 3. Okay, so I also posted a PDF finally, because originally I didn't post the homework, so some students didn't know, don't, maybe they don't have the textbook. Okay, so I will provide the homework PDF file for your reference. Okay, so the first one is about the data library website. So this website is very important because most of finance research papers, okay, they tend to use this data as a basic data to help them to develop their analysis on the portfolio performance. So this is a very important data website. So you need to know a little bit more about this website, including the data. So I think you can spend some time, okay, reading the notes, okay, on this website. So I think it's totally up to you, okay. But here is exercise. For example, you need to go to the Kenneth French data library, so that you need to download the data, okay, and then you have to do some statistical analysis. So this is very basic statistical analysis. So you have to know how to use some statistical tools you learned before, okay. So I believe all of you have taken the statistics course already. So if you didn't, if you haven't taken this kind of course, you probably need to study by yourself. But basically, this is not that difficult. Okay, so I think this is required. So the first question is to split the sample in half and compute the standard deviation, mean, standard deviation, skew, and kurtosis, etc. Okay, so this is about the chapter 5 and chapter for the CFA 1. I think this will be a lot easier for you, okay? So for other questions like chapter 6, okay, chapter 6, we have 3 questions here, including some CFA questions. So these questions are just to help you to become more familiar with the utility functions. So I think we mentioned that before, okay? So that won't be very difficult. Okay, so let's move on to our chapter. Okay, chapter 8. So today we're supposed to discuss chapter 8. Okay, just a minute. Okay, chapter 8, the title is about the index models. Okay, so index model is very important because we tend to use some index, okay, as a benchmark to evaluate our investment performance. So for example, the easiest example is that, okay, how your portfolio is doing or performing compared with the market index. Okay, so for example, like most people like to use S&P 500 and NASDAQ, okay, index as a benchmark to compare your portfolio performance. So that's usually that's the most commonly called index models. Okay, but theoretically, we have a global. We tend to use a global index, not just completely limited to the specific country like USA. Of course, most people like to use the My Financial Market USA as a proxy for the global market. However, it is not. Okay, it is not. So I like students to view the economy of the world, okay, as a proxy, okay, which can be used to compare with your portfolio performance. So you shouldn't limit, okay, your analysis to the to specific market of specific country, okay. But in fact, people like to use USA USA financial market as a proxy. That's a very common case. But what I mean is that, okay, you should develop your global view, okay, a global economic view. So for example, right now in Asia, what really happened in the Asian financial market in the last week, okay, so you should put your focus on this. And more than that, maybe you shouldn't limit yourself to just selecting investment target. You should include other information like, for example, like commodity prices, foreign exchange prices, okay, foreign exchange rate. Okay, so recently for example, last week I just saw news on YouTube discussing about the appreciation, possibility appreciation of Japanese yen. Okay, so this is very recent news. Okay, so what do you think about? Maybe you should think about, okay, what really happened to the Japanese yen? Is there any profitable investment opportunity to see maybe there's a chance for Japanese yen to appreciate in the short term? Okay, so if that's the case, then you should consider about the interest rate of interest rate of Japan. Okay, because the exchange rate of Japanese yen, okay, is strongly related with the interest rate in Japan. Okay, so we know that in Japan, the low interest rate, okay, or almost close to zero interest rate, is a very common case, okay, in the past decades. But now, maybe the Federal Reserve Bank of Japan is trying to change the direction of the interest rate. Okay, so but why is that? You should think about that. Okay, you should think about why Japan is planning to change its interest rate policy. Why Japan is planning to change that direction. Okay, is it because of the high inflation rate? Okay, so because Japan is, I think Japan is the second or the largest, should be the second largest economy in Asia. Okay, so now we should care more about what really happens to Japan, of course, including China. Okay, so we have to pay very close attention to this. Maybe you are interested in traveling, planning a travel to Japan in the near future. Maybe that will be more important to you. Okay, maybe you can buy some Japanese yen. Okay, and waiting for the Japanese yen to appreciate in the near future, maybe in the next 3 months. Okay, whatever. So, but what I mean is that you should put yourself, okay, on a higher position. Okay, not just thinking about, okay, what is going on, what's the index changes in S&P 500, Nasdaq, okay, etc. In fact, the changes in this financial market don't really, sometimes don't really have any relationship with our lives. Okay, of course, now we are talking about investment. What I mean is that your selected ETFs, your selected investment target shouldn't be limited to stocks. Okay, what I mean is that there are so many ETFs out there in the market. Have you thought about buying some exchange rate related ETFs? Right? Not just the stock related ETFs or index related ETFs. You should think about exchange rate ETF or interest rate related ETF, for example, like bond related, bond price ETF, etc. Okay. Of course, we also have many different types of ETFs like commodity markets, okay, commodity prices, including oil, etc. Okay, so let's just have a overview of this chapter. Okay, so we mentioned something about the portfolio construction in chapter 7, right? in that chapter, we need to do some statistical calculation, or we have to derive some basic statistical metrics. For example, like expected return or average return, and of course, including the covariance metrics. Okay, but there are some problems using these statistical approaches. Okay, so what we are talking about now is about the drawbacks to the Markowitz procedure. Maybe you will be a little bit confused with the Markowitz, but what is Markowitz anyway? But don't be afraid of this term, because Markowitz basically, of course, it's a pioneer in the portfolio analysis. But what we like to emphasize is that Markowitz just use an optimal algorithm to derive the optimal weights for the portfolio investment. Okay, so what we are talking about, the Markowitz procedure, is basically a process of optimization algorithm. That's it. Okay, we have a target function, for example, like we try to achieve a specific level rate of return on our portfolio. However, on the other hand, we also have to set up some constraints, conditional constraints. For example, like in the same time, we like to minimize the risk of the portfolio. Okay, so that's one way we mentioned before. So this is just a process of optimal optimization process. Okay, we have a target function. We can also set up a few conditions, okay, or constraints, and finally we can derive the optimal weights for our assets investment. So we call this process or procedure as a Markowitz procedure. Okay, so the drawback to Markowitz procedure requires, there are several drawbacks. First one is requires a huge number of estimates to fill the covariance matrix. So for example, if we have many assets, okay, we have so many assets, we need to estimate the covariance matrix. Okay, and then a model does not provide any guidelines for finding useful estimates of these covariance or the risk premiums. Okay, so we just the Markowitz process just tells us how to find the covariance matrix. Okay, but it doesn't mention a lot about the problems of using this covariance based on statistics. Okay, because we know covariance actually is just a measure, okay, to describe the relationship among assets. However, this is not the best way to construct our portfolio using the covariance matrix. Okay, so this is the problem. So in this chapter, we're gonna introduce different approaches. So this is we call this is index models. Okay, so index model means there are some advantages. Here is one, simplifies estimation of the covariance matrix. Okay, and the second one is enhances the analysis of security risk premiums. Okay, so we'll talk about this later in more detail, but basically it can save us a lot of time deriving the optimal weighting for each asset in our portfolios, and on the other hand, it can also help us to achieve or reach our investment goals. Okay, conditional on these constraints. Okay, so this is the most commonly used approach right now in the portfolio analysis. So okay, so the first one is about the single factor security market. Okay, So the single factor, which means that, okay, we only consider one index, okay, market index. So the advantage is a single index model. Number of estimates requires a small fraction of what would otherwise be needed. Okay, so we can decrease the number of the parameters that we need to calculate the covariance matrix. Okay, so that can save us a lot of time. And then and the specialization, the effort in security analysis, maybe we can put more effort in security analysis, okay, instead of just focusing on the estimation statistical measures. Okay, so now we have the first equation. This equation is very important. So now we try to, maybe you can try to imagine that, okay, what's the factors, what are the factors driving the return for specific assets, okay? What's the factors driving the return of your selected targets? For example, like I know some students like to invest in Bitcoin, okay, because right now Bitcoin is very popular investment. So what are the driving factors, the driving forces behind the Bitcoin prices? Okay, if we replace the Bitcoin with any other stocks, okay, for example, like Apple Computer or Nvidia, whatever, okay, maybe you can come up with many different ideas of factors. Okay, you can tell me, okay, so because why Nvidia is so popular and why the price of Nvidia is so is in such a high price level, you can tell me many stories. But to simplify your story, you have to tell me maybe some theories, okay, about why or what really drives these prices. So this is very fundamental. Okay, now if we treat the global, okay, the global Earth, okay, Earth as a single market, okay, then maybe we can find a factor, okay, drives the return specific assets. Okay, so maybe this is not that easy to realize this. One easy way, okay, one easy way is to find a market index, okay, to you can just use market index, okay, and because the stocks is just the one component of the market index, so that you may say, okay, maybe market index, okay, drives the return of this specific asset. So we can so that we can write this equation as RI equals to expected return plus beta I times N. So N is the market index, market return, okay, and plus the residual terms. Okay, so this is just the equation to derive the relationship between RI and the market index, market index returns. Okay, but maybe for some stocks it really works, but maybe it's not working for some specific stocks. So sometimes we will call this as a regression model. Okay, so if you haven't learned any regression model, you can just treat this function as a linear function. Okay, we try to find a linear relationship between asset returns and market index return. That's it. Okay, and finally we have a residual term. So this EI is called residual terms, and this is to explain something that the market index return cannot explain. Okay, so so the most interesting thing is about these residual terms. Okay, but hopefully we can run this equation first. Okay, so beta I here is the sensitivity coefficient for firm I. Okay, and the M is a market factor that measures unanticipated development in the macro economy. Okay, so now maybe it's a little bit difficult for you to understand what the market factor is. What the market factor is. So in theory, the market factor actually represents the global market. Okay, because we are the resident, okay, of the earth. Okay, so maybe we can just minimize the market, the global market, to become just one market. Okay, and then you can treat this market factor as the global market. Okay, but in just like I mentioned, in reality, sometimes it's not that difficult to imagine this condition. Okay, so most of the time we will use the largest financial market, for example, like USA market, as a proxy for the market factor. Okay, but of course, we also have developed different ways, okay, to generate these market factors. Okay, so there's no problem at all in generating this market factor. To put it another way, maybe we can just treat the financial market on the earth, okay, as a portfolio, so that you can just combine every financial market as a single asset, and you can try to combine this financial market, okay, together to become a single portfolio, and finally you can generate a market factor. Okay, but now we can just imagine that, okay, we can find we just use the market index as a proxy for the market factor. Okay, so for example, like if you want to analyze the Apple computer rate of return on Apple computer on the left hand side, and then you can use the financial market of USA as a market factor. Okay, and so that you can estimate the beta. So the beta here refers to sensitivity coefficient for firm I. Okay, and the EI refers to firm specific random variables. So for this term, there are lots of stories, okay, behind this EI to explain some abnormal returns. Okay, so usually if this return Ri moves very closely with the market factor returns, then the beta I should be very close to 1. Okay, so that means, okay, this is a good, very sensitive to market index. This stock, okay, is very sensitive to market index return. However, for some stocks, okay, they are not moving so closely with market index return. Okay, so this kind of stocks can be grouped into different stocks. Okay, so maybe this kind of stock can diversify our investment risk in our portfolio construction. Okay, well, we'll talk about this a little bit more later, but just this equation just to help you to understand. Okay, now we have an equation to help us to simplify the derivation of the returns for specific assets. Okay, so basically now we have a factor, okay, to explain the stock returns or asset returns here. Okay, so now we have a equation, a regression equation. Sometimes we call this a regression equation. But if you are not so familiar with the regression equation, don't worry. It's not that difficult in R. Okay, so talking about the R, if if you still have problems in running R or Markdown, you can tell me, and then maybe I can find some students to help you, because taking my course last semester. So if you want to know a little bit more about R, okay, you can tell me, okay. So, but basically it's not that difficult because there are so many resources on the internet. Okay, you can just find a book and watch some videos, and then you will be able to do that. Okay, so now we have a regression equation. Okay, so now we have after we run the regression equation, we have a expected return beta relationship. Okay, so this is about the single index model. Okay, so after we take the expected expectation on both sides, on the left hand side and right hand side, then we have the residuals. Okay, EI of t. Okay, what the expected value of EI of t will become 0. Okay, so that's the final equation here. So we have expected return beta relationship. Okay. So now we have we can assign different notations to this equation. Okay. So first of all, we have a total risk. Okay. Maybe we can define the total risk. Why is that? Because if you go back to this equation, so suppose this equation. Okay. Suppose we have an equation to describe the asset return I and the market return. Okay, then we can derive the variance. Okay, the variance, which means we can take the variance on both sides, right? So what it means is that maybe we just take the variance on both sides, okay, and then we can derive this result. Okay, so on the left hand side, we call this as a total risk. Okay, and on the right hand side, we have a systematic risk plus firm specific risk. Okay, so this is the total risk. So that means we can decompose the risk of the asset I into two parts. One belongs to the market risk. We call this a systematic risk. Okay, the second component is called a firm specific risk. Okay, so this is very straightforward. Okay, so what I mean is that you take the variance. Okay, so for example, in this equation, you take the variance. Okay, maybe I should. Okay, you take the variance on the left hand side. You also take the variance on the right hand side. Okay, and then finally, you will get the variance of Rn and the variance of Fei. Okay, so finally you will get the results. Okay, so this is how we decompose the risk of our investment. Okay, and based on this, we can also derive the covariance of the two asset returns. For example, like we have Ri and Rj. Okay, so now if we want to derive the covariance, okay, we can think about that. Okay, since both stocks returns or asset returns are completely affected by single factor, which is market return. So if we want to derive the relationship Ri and Rj, so that means we can simplify the results. Okay, after derivation, we'll get the beta I, beta multiplied by beta j, and multiplied by sigma n squared. Okay, so we'll try to derive the relationship later. Okay, but there's a more detailed explanation of this equation. Okay, so we'll cover that later, okay? But now it will be more easier for you to calculate the covariance between two assets. Okay, so this is about covariance. And then we can, based on this, we can also calculate the correlation. Okay, so the correlation, well, this is just the different ways to express the relationship between two assets. So that is defined as the product of correlations with the Mach index. Okay. Okay, so based on this, okay, so now suppose we have a portfolio, okay, containing n companies, okay. So the variance of equally weighted portfolio firm-specific component, okay. So you can try to derive the results based on this equation, okay, and then finally you will get the results. Okay, so this is the variance of the equally weighted portfolio firm-specific components. Okay. And when n gets large, okay, and this variance of the residuals will become negligible. Okay, so this, in other words, as the diversification increases, that means if we increase the number of assets in our portfolio, the total variance of a portfolio approaches to the systematic variance, which means if n becomes larger and larger, okay, and then the sigma square of EP will be close to 0. Okay, so that means because if we include so many stocks in our portfolio, you can just imagine that if we include all of the stocks in our portfolio, okay, on the earth, okay, we include all tradable assets in our portfolio because n is so large, so that the residual risk of or individual risk coming from each assets will be cancel out each other. And besides that, as n becomes larger, okay, and the sigma of the residual portfolio variance will become closer to 0. Okay, so this is a mathematical problem because if n is becoming larger and larger, and this value will be close to 0. Okay, I'll put it in the plotting. Maybe you can understand. In this plot, we have sigma p square on the y-axis. So this is the portfolio risk. Okay, and remember, portfolio risk contains two parts here. Okay, the first part is sigma n, the second part is sigma ei, but this is for asset I. Okay, but if we include many assets in our portfolio, and this value will be close to 0. Okay, so that you can see this is a downward trend, and this will be very close to 0. And finally, what is left here in our portfolio risk is only systematic risk. We call this as a systematic risk. Okay, so and then the most important factor will become the beta p squared times the sigma n squared. So sigma n, okay, will be the most important factor in explaining the portfolio risk. Okay, so let's take a break, okay, and then we'll be back later.